Hello everyone, now we're going to solve physics October-November 2024 paper 2-1. Number 1. A student uses a meter ruler to measure the length of a sheet of paper. Which measurement is shown to the nearest millimeter? Now to solve this problem, we have to know the relationship between meters and millimeters. And we know that 1 meter is equal to 1000 millimeters. So we need to look for the answer that has 3 decimal places, and that will be B. Number 2. A rocket travels with an average speed of 6 kilometers per second for 2 minutes. What is the distance traveled by the rocket? And we know that the distance traveled is simply average speed multiplied by time taken, but we have to be careful of the different units here. So we multiply 6 and then 2 into 60 to convert that to seconds, and we get 720. Number 3. The diagram shows the vertical forces acting on a ball as it falls vertically through the air. The ball does not reach terminal velocity. Which row describes what happens to the resultant force on the ball and what happens to the acceleration of the ball as it falls through the air? Now to solve this, we have to know this equation, which is resultant force equals to mass into acceleration. And we have to know this because it shows the relationship between resultant force and acceleration, which is directly proportional to each other, which means that if force increases, then acceleration would increase. So you can just exclude B and C. And now you have to think about whether air resistance would increase or decrease. Now when there is acceleration, the velocity would always increase, which means that the object, it would have to face more air particles per unit time, which means air resistance would increase with velocity. So if the air resistance increases, and weight stays constant, then the resultant force, which is the difference between these two arrows, it would definitely decrease. So then it would be A. Number 4. A coconut falls from a palm tree. At X, it had just started falling. Y is the point just before it hits the ground. What is the acceleration of the coconut at X? Air resistance can be ignored, and this means that it's free fall. So at free fall, the acceleration of any object is just 9.8 meters per second squared. And because this is just a palm tree, the distance cannot be like that high, and on the Earth's surface, the acceleration remains constant. So it will be the same, C. Number 5. A car is driven round a bend in the road at a constant speed. What is the direction of the resultant force on the car when it is going around the bend? Now we are thinking about circular motion, and it involves centripetal force, which is always going to be towards the center and perpendicular to the motion. So you can read through the options, and the answer would be C. Number 6. The diagram shows a drawbridge that is attached to a wall by a hinge at one end and a cable at the other. The weight of the drawbridge and the tension in the cable are represented by the labeled arrows in the diagram. There is a third force at the hinge, which is not shown. The drawbridge is in equilibrium. Because it is in equilibrium, you need to know that there is no net force, no moment. Which arrow shows a possible direction for the force at the hinge? So as I mentioned before, there is going to be no resultant force, no net moment. And when you see these arrows, I don't know for you, but it just reminds me of the vector diagram. So we use that method. And there are like 2 ways of constructing a vector diagram, and now we use one of them. And now this is weight, and it's going to be tension, just, This is going to be tail-to-tail method, right? So the resultant force would be this one. From tail to tail, between two tails, and then you get the resultant force. But I just mentioned that there will be no resultant force because of this third force, right? We still have this third force, which means that third force has to cancel out this resultant force that we have right here. So we will draw in the opposite direction with the same magnitude, and which is going to be D. Number 7, which equation gives you the momentum change of an object? So I hope you remember the equation. Momentum is just force into time, and you can actually prove this, right? So we know that momentum is mass into velocity, and then force is equal to mass into acceleration, and force is also equal to mass into acceleration is just velocity divided by time. So you can replace momentum in here, so that will be force is equal to momentum divided by time, and if you want the change in momentum or just momentum, you multiply the time with the force. So it is just the same thing. So number 8, which statement about the use of the nuclear fuel as an energy resource is correct? So nuclear fuel is just the energy, the fuel that you get from the nucleus of an atom. It's really obvious. So it obtains its energy from the sun. Now this is not really true. We call that solar energy. And it has no environmental impact. This is also incorrect because the nuclear waste it's a huge deal in terms of environment and stuff, because when it decays and emits radiation, it does harm the living things around the surroundings. So that would be wrong as well. And the nuclear power stations do not need turbines. This is also not true because the turbines, they're really essential in generating the electricity, because so the whole point of this is to take the energy, right, from a source, and then you make the turbine turn, convert that to kinetic energy, and that's how you generate electricity. So C will be wrong as well. Indeed, the energy is released by nuclear fission, and when fission happens, a large nucleus splits into smaller ones, and then it loses mass, and that's why you get energy according to E is equal to mc squared. So then D would be the correct answer. So number 9, the diagram shows an object of mass m being projected with speed v from a point P to a point Q on top of a cliff height h. The object does work W against air resistance as it travels from P to Q. What is the kinetic energy of the object when it reaches point Q? So now you can see that the initial velocity, right? The initial kinetic energy, it would be 1 minus 2 mv squared, because that's the equation of kinetic energy, and mgh is the equation for gravitational potential energy, and W is just work done against air resistance, and you have to consider whether these mgh, GPE, and the work done against air resistance would be decreased, would be taken from the initial kinetic energy, or would they add to it, something like that. Intuitively and apparently, because you have to do work against air resistance, it will be lost, so you would want subtraction, and because you gain height, you have to give some GPE for that from the initial velocity, so then it will also be subtraction. So the correct answer is D. Number 10, the diagram shows a Sankey diagram for an electric drill. what is the total wasted energy shown by the diagram. So here you see a Sankey diagram, and these two are just wasted energy, right? Because the arrows are pointing downwards, and this is useful kinetic energy, and it wants the total wasted. So you see the scale, you just have to count the squares, right? 1, 2, 3, 4, 5, and they are the total of 5 squares. And then the scale says 1 square will represent 40 joules, so that will be 40 into 5, and it will be B. 11. An elephant of weight 45,000 newtons stands with all 4 feet on the floor. The average pressure on the floor due to the elephant foot in contact with it is 34,000 pascals. What is the area of each foot of the elephant? So you have to know the equation, which is pressure is equal to force divided by area. And to get area, you have to divide force by pressure. And total area would be 45,000 divided by 34,000, and you will get 1.3235, something like that. And that's only the total area of all 4 feet, but we want the area of each foot, so you have to divide that by 4 again, and you get 0.33, so on. So the answer would be B. 12. Some air is trapped inside a metal container with a tightly fitting lid. The container is heated strongly behind a safety screen. The lid is blown off by the increased pressure of the air inside the container, which causes the increase in pressure of the air inside the container. Number A is each particle expands and takes up more room. Now, each particle doesn't really expand like that, so they just stay the same, just the space between them gets larger. So that would be wrong. And the air particles move more quickly. Now that is correct, because it is heated. When you give heat energy, now this will be taken as kinetic energy by these particles, so they move more quickly. And when you look at number C, the number of particles inside the container increases. Well, that doesn't really make sense because it is tightly fitting lid, and that means nothing comes in or out, so that would be wrong. And the volume occupied by the air decreases. Now this is really counterintuitive because the lid is blown off by the increased pressure, which means it needs more volume and space, so you cannot decrease. Number 13. A very hot mug of coffee is near a large and heated swimming pool holding 2.0 into 10⁻⁶ kilograms of water. Which statement is correct? If the mug of coffee is tipped in the pool, the coffee will lose much more internal energy than the water in the pool gains. Now this is directly tipped in the pool, and when you pour stuff directly into it, there is no way of losing energy, and even if it loses energy into the air surroundings, it will not be much more. So that doesn't really make sense. I mean, this could be true if the other 3 options don't make sense at all, but right now is not sure. So the idea is that you give something like internal energy or heat energy, then the recipient should receive most of it, So number B, the internal energy of a substance depends only on its temperature. Now this is not true. The internal energy by definition is the total energy of potential energy and kinetic energy, so not really the temperature. The internal energy of the water in the pool is lower than the internal energy of the mug of coffee. And when you just think about it, this looks kind of true because the coffee is hot and the water is cool somehow. So, but you can't really assume that, as I mentioned. The internal energy of an object is the total energy of all the kinetic energy and potential energy of all the particles combined. So you have coffee, just a mug. It's a small volume, but now you have a very large swimming pool, and there are many more particles than here in the mug. So this could not be true as well. And number D, when the temperature of the mug of coffee falls, its internal energy will decrease. Now this is like the most logical explanation or statement, because when the temperature decreases, then the kinetic energy will definitely decrease. Then the internal energy will decrease as well. So 14. A student measures the mass of water in an open container over 2 hours. The container is kept in a warm room, and the results on the table. And I'm just getting through the results, and you can see that the mass decreases, and it asks for why the mass changes. So it's obvious the water evaporates and the molecules, they escape. So the mass decreases, and the others don't really make sense. I mean, the mass doesn't really change when you go through a phase change, so only evaporation. So number 15, 1 kilogram block of aluminum requires more thermal energy to raise its temperature by 1 degree Celsius than a 1 kilogram block of copper requires. So when you just look at this thing here, you should really see the definition of specific heat capacity. So this has not really anything to do with being a poor or good conductor, so we can eliminate. Now, as I mentioned, this is like the basic definition of specific heat capacity. Now we can analyze the given information. So aluminum requires more thermal energy. Now I just have to remind you of the equation, right? So specific heat capacity is equal to change in energy divided by temperature change and mass into T. So it just requires more energy, which means it is directly proportional to specific heat capacity. So then it means that if aluminum requires more thermal energy, then it means it has a higher specific heat capacity. So that would be C. 16. A block of ice at a temperature of -100 degrees Celsius. Energy is applied at a constant rate. The graph shows how its temperature changes. At which points have the ice completely changed state to water and all the water completely changed state to steam. And you have to know and remember that when you see like graphs like these, when phase is changing, that the temperature is not changing. When the temperature is changing, that the phase isn't changing. So you have to look. Now it just asks for points, so it doesn't really matter. So because it says completely changed to water, then we want to choose like the upper end of the numbers. So that will be 2 and 4 completely changed, and that will be D. 17. Water waves are reflected at a plane surface. Which property of the waves is changed by reflection? Now just to give you a general idea, right? So if it reflects, right? Something reflection, so this is a wall, and then you have something like the direction here, and then because it is reflection, this is the incidence, right? It's not particularly a ray, but this arrow just represents the direction of propagation of the waves. Since it reflects, that will be in this way. So apparently that will be the direction, right? Changed by the reflection. And normally the frequency, speed, wavelength, they don't really change just because of reflection. So that will be A. And 18. A light ray is passed through the air, glass, and water. At which point does the light speed decrease? Speed of light decreases when the ray gets closer to the normal. So you see that at W and Y, they kind of decrease, get closer to the normal. So that would be W and Y, and that would be B. So 19. Plain water waves approach a narrow gap in the barrier, which diagram shows a diffraction pattern would occur. So if you look at A, doesn't look quite nice because the waves are like really small like this. In reality, it isn't really like that. It would be really large, either B or C. D doesn't really make sense as well. And the difference between B and C is the wavelength. And when diffraction and reflection happens, those wavelengths doesn't really change. So that would be C. 20. A ray of light enters a transparent plastic watch from air and is incident on the lower surface at a critical angle as shown. So this would be the critical angle. The angle of incidence I is the angle the angle of incidence is I and the angle of refraction is R, and the critical angle is C. In which ray diagrams are the angles labeled correctly? Well, I'll just mention one of the answers. So by definition, critical angle is the angle of incidence. It is the minimal angle of incidence beyond which total internal reflection happens. So basically, at critical angle, you would get the refracted ray traveling along the boundary at 90 degrees here. So this is the angle of incidence, in other words, critical angle. So you would want to choose from B and C. And apparently, you have to look at the angle between the ray and the normal, and not the surface and the rays between the normal. So right, normal is there for a reason, because we want to determine the angle of incidence and reflection. So that would be B. 21. An object is placed 20 centimeters in front of a thin convergent lens. The scale diagram shows how the lens forms a real inverted image. Which rule gives the focal length of the lens and the distance of the image from the lens? So we choose from the easier one, right, that you can see. So we think about the distance of image from lens, and that is, this is the center of the lens, and you can see this is 5 centimeters. So you can just choose the 5 centimeter one. But we'll make sure with the focal length, right? So focal length is just this place, because when the parallel ray to the axis passes through the lens, it would pass through the focus from the other side. So I assume that there are like 10 squares in 10 little squares in one big one. And the scale is like 5 centimeters. so you can assume that 2 small squares mean 1 centimeter. So you can choose A. 22. Radio waves are electromagnetic waves. What is the wavelength of a radio wave of frequency 2.0 into 10^5 Hertz? So this requires you to know the speed, so right? You know the wave equation, which is velocity is equal to frequency into wavelength, which is lambda. So I'll just write it like this. And velocity is just 3.0 into 10^8 meters per second, because it's a electromagnetic wave. So you want to find lambda. That would be 3 into 10^8 divided by 2 into 10^5, and you will get 100 meters. D. 23. A candle flame is placed in front of a loudspeaker. The loudspeaker produces a sound wave that causes air particles to vibrate, and the vibrating air particles make the candle flame vibrate in the same direction as the air particles. Which row shows the direction of vibration of the candle flame and the nature of sound waves? So, as you all know, nature of sound waves is longitudinal because its propagation is like parallel to the wave travel, to the direction of wave travel. And as I mentioned, it's parallel, so this will go back and forth like this. So we can just see. Okay, so 24. The diagram shows part of the magnetic field around a strong magnet. In which position does a magnetic pole experience the strongest force? So the strongest force means one drawing showing in a diagram. It means to have like the densest lines, like the most lines at a particular point. In this case, it will be A. 25. There is current of 0.60 amperes in a closed circuit. How much charge passes a point in the circuit in 2.5 minutes? So you have to know this equation, right? Charge is equal to current into time, and the time is in seconds. So current is just essentially like how much charge passes through a point per unit time. So Q is 0.6 into 2.5 into 60, and that will be 90 coulomb. And that's C. 26. Which two physical quantities have the unit joules per coulomb? Charge and energy. Well, that's not true because those are like separate things, right? Joules is for energy and charge is for coulomb. And now we want the quantity that's divided, so that's not true. Charge and potential energy. Now you can eliminate answers that contain charge and energy. So that just leaves us with C. And by definition, potential difference and electromotive force, they're quite similar, and they just mean like how much energy you need to move a single charge around the circuit or through a component. If it's around the circuit, then you're talking about EMF. If it's through a single component, then you're talking about potential difference. So 27. A copper wire is placed in an electrical circuit and its resistance is measured. The wire is then replaced with a second copper wire with twice the length and a quarter of the diameter. And what is the ratio of the resistance of the two wires? So I hope you know the equation for this. But you don't really have to learn the equation. Yeah, but you have to know the relationship, right? So the resistance is directly proportional to the length and inversely proportional to the diameter squared, and that's because it is inversely proportional to the area. And to find the area, you have to take the value of squared diameter somehow, because you're looking for area. So we use these two to determine that, and it asks for twice the length, so you can assume that the new resistance would be twice as large, and then a quarter of the diameter. That means the diameter gets smaller. So when the diameter is smaller, then the resistance is going to be larger because they're inversely proportional. And by squared, so that will be 4 squared, right? A quarter means 4, so 4 squared, and you get 16 into 2, that will be 32, so you get D. So 28. Which circuit contains a diode connected in series with a fixed resistor? So you just asked if you know the symbols or not. And diode, it looks something like these, something like this. The fixed resistor doesn't really need an arrow because it's fixed. And 29. In the circuit shown, resistor X has twice the resistance of resistor Y. Which statement about the circuit is correct? No, this guy has twice the resistance. So the current in the cell is greater than the current in X. Well, apparently yes, that's true, because this is a source and the current has to divide in parallel circuits. So the current through X and current through Y, and the sum of them will be equal to the current in the cell. So it is true, but let's explore the other options as well. The current in X is greater than the current in Y. Well, the resistance literally means resistance. It doesn't really want current to flow, so current will decrease in X, so that is wrong. The potential difference across the cell is greater than the potential difference across X. Well, that's not true. Potential difference is the same across parallel circuits. And because that's the same, the D would automatically be wrong as well. And 30. A 4 ohms resistor and an 8 ohms resistor are connected in series with the power supply. A voltmeter connected across 8 ohms resistor reads 36 volts. What is the voltmeter reading when it's connected across the 4 ohms resistor? So you know the equation, Ohm's law, to go to V is equal to IR. That means voltage and resistance, they're directly proportional. So by factor, obviously, and you can see that if it decreases by 2 times, right, the resistance decreases by half, so this will also decrease by half, so that will be ATB. 31. A metal rod XY is placed in magnetic field so that it is perpendicular to the field as shown. In which direction is the rod moved so that there is an induced current from Y to X? So when the question says something like you have to move it first, there's going to be movement first, and then this will induce the current, then you have to use your right hand for Fleming's right hand rule. So I'll just draw something like this, right? So the 3 fingers, your thumb, your index and middle fingers, they have to be perpendicular to each other. And first thing you have to do is point out, this is magnetic field, right? So this is represented by index finger. So you have to point it towards the right. And then thing y to x, it would come by the middle finger, y to x upwards. And when you do that with the right hand, you can see that this thing is coming outwards, coming towards you, right? So then that would be D. 32. The diagram shows a basic electric motor. What are the names of the features? So X, what is X? X is just coil of wire, so obviously it is B. And this guy, Y, it is called carbon brush, just used to conduct the electricity into here. And then this is called the commutator, which rotates in the motor. So 33. Two transformers P and Q each have 2,000 turns on their primary coils and 1,000 turns on their secondary coils. Both transformers are 100% efficient. The secondary of transformer P is connected to the primary of transformer Q, and Q provides the motor with a current of 0.2 amperes. What is the current being supplied to the primary of transformer P? So I will draw a thing here. So let's call this transformer P and let's call this transformer Q. And let's say this is secondary coil because it is going to be connected to the primary coil. And that means that current in primary coil of this Q will be the same as here. And we know that both transformers are 100% efficient. And the thing that you have to remember when you see this given fact is probably to use the concept of power. More on that later. We will firstly think about the relationship between the number of turns and the current. But there isn't a direct one that we've learned in here. But we've learned about the number of turns and the voltage. And what it says is that NP divided by NS is equal to VP divided by VS. Now we'll think about power as well. So power is equal to current multiplied by voltage. And if you want current, you divide power by voltage. And this means that they are inversely proportional to each other. And in this relationship, you can see that these two, they are directly proportional to each other. So if current is inversely proportional to voltage and voltage is directly proportional to the number of wires, then you can probably assume that the current is inversely proportional to the number of wires. So what I'm trying to achieve in here is that also you have to think about whether this 0.2 ampere is in the primary coil or secondary coil of transformer Q. So here it means that it provides a motor, which means the coil is connected to another electrical appliance, and that's usually done in the secondary coil, obviously, because in primary coil you have the power source and input and stuff. So that means you can assume that the secondary coil has 0.2 amperes. And we just realized that if the number of wires increases, then the current would decrease. And the factor would be half, because here you've got twice as many turns in primary coil than the secondary coil. What I'm trying to say is that if you have 0.2 amperes in here, then you only have half of it. 0.1 ampere in here. Because of, these two, they differ by a factor of 0.5. And primary coil has more turns, which means the current is going to be less. So in secondary coil, you also have 0.1 ampere because they're connected. They have the same thing. But we want the primary coil. So in primary coil, once again, we have more turns. So we'll have it again, right? So now we're left with 0.05 amperes, and that will be D. 34. Alpha particles are directed at a metal foil. Most of the particles pass through the foil with little change in direction. A small proportion of the particles are scattered back through the large angles. What does this evidence suggest about the structure of an atom? It consists of a charged center, much smaller than the size of the atom, with little of the mass of the atom. Now, to this point, it was okay, it was correct. But actually, the nucleus is really dense. Even though it's small, it occupies most of the mass of the atom, so A is wrong. B, it consists of a negative charge, the size of the atom, containing small positive charges scattered through it. Now you see the word scattered in an atomic model, and that's not true, because the electrons are orbiting in the shells, and then the protons and neutrons are just, very tightly packed in the center. So it's wrong as well. C, it consists of a charged center, much smaller than the size of the atom, but with most of the mass of the atom. Now this is what I was talking about. This is the opposite of A, and it contains most of the mass of the atom. So this is true. Now let's look at D. It consists of a positive charge. The size of the atom containing small negative charges scattered through it. Once again, it has this word, then this is going to be wrong. So 35. Which statement correctly compares the properties of alpha particles and beta particles? A. Alpha particles are less penetrating than beta particles because alpha particles are less ionizing. Now this is not true. Even though it's true that alpha particles are less penetrating, they're not less ionizing. They are in fact more ionizing because of a larger charge. And because they are more ionizing, they are less penetrating. Now the thing is, to penetrate through an object, you have to go through it and change it. But then if you're ionizing, then you're going to ionize other particles, interact with other atoms, then you're going to be changed, and you don't have that much energy or charge anymore since you're very ionizing. So alpha particles are true. It's true that they are less penetrating but more ionizing. B. Alpha particles are less penetrating than beta particles because the alpha particles are more ionizing. Now this is true. Now you can see that this is the opposite thing of A, so it could be true if A is wrong. Let's look at C and D. Alpha particles are more penetrating now. They're less. So yeah, both are wrong. 36. Which statement about alpha decay is correct? The nucleus loses electrons. A. And B. The nucleus changes to that of a different element. C. The nucleus does not decay until after 1 half-life, and D. After 2 half-lives, alpha decay always stops. Now if you look at A, nucleus loses electrons. The nucleus does not contain electrons. It only has protons and neutrons, so that would be wrong. And the nucleus changes to that of a different element. Now this is true because if alpha decay happens, then 2 protons and 2 neutrons, they would be emitted, which means it's the nucleus of a helium atom. So this is true. Because proton number changes, then it becomes a different element. And the nucleus does not decay until after one half-life. Now that's not true. The meaning of half-life is just like the time taken for half of the thing to decay. So the thing, like the nucleus, will be decaying, but only when the rate or the left mass is like half of the original one. It's called one half-life. So that's not true either. And after two half-lives, after decay always stops. Now there's no such rule as that. So that would be wrong. 37. An explosion in nuclear reactor spreads the isotope cesium-137, cesium-55 across a large area. After 90 years have passed, the quantity of cesium-137 present is 12.5 of its original level. What is the half-life of cesium-137? Now, as I mentioned, half-life is the time taken for half of the cesium-137 to decay. So we have some original stuff here. Let's just say it's X, and then we've got half-life, so it's going to be 1/2. 1/2, and then we write the number of half-lives in here, and it's going to be equal to the left one, right? The left one. So original 112.5% of the original cesium-137. So you can say that these X, they can cancel. And I'll just have to look for this little square. And this is a bit of like some math. Now, if you convert this percentage into an actual, like the number, then you get 0.125. And that 0.125 is actually equal to 1/8. If you don't believe that, you can just put that number in a calculator and it will show you the fraction. And what it says is that 1/2 to the power of this little square is equal to 1/8. Now, if you're good at math, you already know that that little square will be equal to 3. And that means that after 3 half-lives, 90 years have passed. So for one half-life, you can divide it by 3, then you get C. Okay, so 38. Which type of object rotates around the sun with an elliptical orbit? Apparently you already memorized it. That is planet. Now, there's 8 planets in the solar system. They orbit with an elliptical shape, and honestly, the other 3, they don't really orbit the sun, so it doesn't really make sense. So 39. Which statement about the sun is correct? The nuclear reactions in the sun create mainly radio waves and microwaves. Now, this is not true. It does not really mainly produce these waves. In fact, it produces visible light and ultraviolet more than these two. And B, the sun is powered by fission reactions in which hydrogen is converted to helium. Now, fission is like splitting, so you can't split a very small element into a larger one. This doesn't make sense. And C, the sun is powered by fission reactions in which lithium is converted to helium. Now, in fact, the sun does not have like fission reaction. It is powered by fusion reaction. And hydrogen is like the lightest and the simplest element, and when they fuse to helium and stuff, there's a loss in mass, and that's where we get the energy. So the answer would be D. 40. To determine the value of the Hubble constant, an astronomer measures the distance of a galaxy from the Earth as 2.5 into 10^21 kilometers. She also measures the speed of recession of the galaxy from the Earth as 5.2 into 10^3 kilometers per second. And from these data, what is the value of Hubble constant? Now, if you already remember what the Hubble constant is, you can just choose the closest one from here, but you can actually use the equation that you learned. And that's going to be the velocity of recession is equal to Hubble constant, h naught, into distance. And if we use a calculator, you can see that velocity 5.2 into 10^3 divided by 2.5 into 10^21, you get 2.08 into 10^-18, and in two significant figures you get 2.1. So this would B would be the correct answer. So this is the end. Thank you very much and good luck with your studies.